Hi to everyone. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject analog devices and circuit, unit number 2. So this is the syllabus for unit number 2, that is operational amplifier and its applications. So that means in previous unit we discussed with basic electronics, that is BJT, JFET, MOSFET, like that we discussed. By going for high gain amplification, we need a operational amplifier. So op-amp is a short term of operational amplifier. Okay. So in this unit, we are going to discuss about what is operational amplifier. So what are the characteristics of operational amplifier? Then what are the applications uh, available in the operational amplifier, like that we are going to discuss in this chapter. Okay. So let's see one by one. So let's see first, what is operational amplifier? So operational amplifier are linear devices that have all the properties required for nearly ideal DC amplification and are therefore used extensively in signal conditioning, filtering, perform mathematical operations such as add, subtractor, integration, and differentiation. So these are the application basic models of op-amp. So that is for high gain amplification, as well as for addition of two signals, subtraction of two signal, then integration of input signal, differentiation of input signal, like that we can done through this operation amplifier. Basically it is a 8-terminal op-amp. So that is having one inverting input, another one is non-inverting input, power supply, positive power supply, negative power supply, then output, offset null, that is no connection. Like that we have 8 pin numbers. So operational amplifier is fundamentally a voltage amplifying device designed to be used with the external feedback components such as resistor and capacitor between in the input and output terminals. So it is have a two terminal, one is inverting terminal, another one is non-inverting terminal. Inverting terminal means if you are giving input means there is no phase shift in the terminal. But if you are giving non-inverting terminal means it is having 180-degree phase shift in the output. So they did say these other different configuration and specifications of IC741 in the different packages. This is the internal operation amplifier stages. Okay, what is internal? So that is we are giving input as non-inverting terminal and inverting terminal. Then it is given to the input stage and given to the intermediate stage. Then level shifting stage. Final will be output stage. Each stage it will be having different output and process. So main circuit of the operation amplifier is differential amplifier. That is differential amplifier. It is having two transistors with connected with the two inputs. That is V1 and V2. So that is basically the op-amp which is amplify the signal, that is a difference between the two input signal, that is V1 minus V2. So that different value will be amplified using the operational amplifiers. Okay. So this is the complete internal circuit diagram of IC741. So ideally, the op-amp amplifies only the difference in voltage between two, also called difference input in, that is V out is equal to A output open loop gain of V1, V plus minus V2, that is V1 minus V2. So this is the basic construction of inverting amplifier and non-inverting amplifier. So inverting amplifier means we are giving input to the inverting terminal. If the non-inverting means we are giving input to the non-inverting terminal. So these are the different configurations of operation amplifier. That is, we can use as voltage comparator, non-inverting amplifier, inverting amplifier, voltage follower, inverting summing amplifier, differential amplifier, differentiator, integrator. Okay. So these are the applications. Then ideal characteristics of operational amplifier. So what is ideal characteristics? When there is no error. Okay, so normally we can check the ideal condition. It is not practically possible, but theoretically, so when there is no error and high bandwidth and high output, so like that we can use this model. That is in this condition. That is if the operation amplifier is ideal amplifier. So that means open loop gain will be infinity, input impedance infinity, output impedance will be zero, bandwidth will be infinity, zero offset will be zero, then CMRR value will be infinity, sleeve rate will be infinity, and the power supply rejection ratio will be zero. So there is the effect on the temperature. This is the ideal condition. But practically it is not possible. It is having some input and outputs. So this is the ideal transfer curve. These are the ideal parameters, that is open loop gain. And the main function of the operational amplifier, the amplifier is the input signal, and the more open loop gain it has better. Okay, then input impedance, then output impedance, bandwidth, and offset voltage. So this is the difference. Ideal inverting amplifier and the ideal non-inverting amplifier. Okay. So these are the basic models. So differential amplifier. So already we know that uh, the main amplification in the op-amp will be differential amplifier. Okay, that is a high versatility, high immunity to interference signal, lower cost, like that we can define. So V out is equal to differential mode gain, and that is ADM of V1 minus V2. Then differential amplifier with active load. Differential audio circuit. Differential gain, common mode gain. So what is differential gain? If we are giving two inputs are different, that is differential gain. Output will be a differential gain. If we are giving same input to the both terminal, means it will be a common mode gain. So CMRR, the ability of differential amplifier to reject the common mode signal is defined by the ratio called common mode rejection ratio, denoted as CMRR. So for ideal condition, CMRR value will be high, that is infinity. That is CMRR is equal to 20 log of AD divided by ZC into dBs. That is a unit will be dB. So there are four configuration of differential amplifier. That is dual input, balanced output, dual input, unbalanced output, single input, balanced output, single input, unbalanced output. So what means balance? So balance means it is the output taken from the both end. So one terminal considered as a positive, another term considered as a negative. That is balance. If you are taking any one of the input, any one of the side, means it is called a unbalanced. Okay, that's why it is having four types. So let's see one by one. This one is dual input balanced model. That is ரெண்டு இன்புட் கொடுத்துருக்கோம், ரெண்டுக்குமே காமனா அவுட்புட் எடுத்துருக்கோம். ஸோ dual and balanced. Next one, we are giving two inputs, but we are taking one output as from the one end. So that is a dual input unbalanced output. Same as single input and balanced output, single input unbalanced output. Okay, so these are the ideal characteristics and the differential models of the differential amplifier concept of the operational amplifier. Okay, so in this chapter we discussed about what is operational amplifier, what are the specifications of operational amplifier, so what is ideal characteristics, so what is differential amplifier, like that we discussed. Okay, So next class we'll see the characteristics AC and DC characteristics of the operational amplifier. Okay, thank you.